Math is great, math is okay. You will need in life every day. From pandas to functions, to fractions, to formulas.
Alright, you should have noticed from our warm-up that all of them, or yesterday's lesson, is that they were all factored, right? Now, they're not factored. So we're going to go through the same steps. We're still going to make sure that they're factored, get a basic graph, multiplicity, and then graph it. But we're going to have to factor first. So let's factor. I noticed that all of them have a GCF, or they have something in common. What does that cost?
2x.
Oh, 2x. Okay, so that's our GCF, greatest common factor. What's left, class?
X squared minus 2x.
And remember, you can always double check that by distributing. And I need something in there. So just as a quick review, I'm going to show you guys my x and my box method. Remember, you don't have to do this. This does not work. Inside the parentheses, I'm looking for a times c. A times c is what value, class? So remember, inside the parentheses, that'll be 1 times a negative 3, which is negative 3. Class, what's your b value? Negative 2. I need two numbers that multiply to be negative 3, but add to be negative 2. So negative 3, positive 1. And if you watch my previous videos, you realize that if your a value is equal to 1, you only have to do the x. So these two values there are going to go here. So I have x minus 3 and then x plus 1. Class, is this factored now? Yeah, that's the only difference from yesterday's lesson. So now it's factored. Now I'm just going to get a basic graph. I got an x, and x. Class, that means my basic graph is going to be cubic. It's going to be cubic. Odd or even?
Odd.
What's the easiest one we know? So I'm going to start down and up. That's what my leading coefficient tells us. Now we just do our multiplicity. Class, here x is equal to 0. X is equal to, and x is equal to 1. What's our highest degree here? Remember, if you get confused, you can also think of this as 2x minus 0 to the first power. And these are all ones. Odd or even? And what do you do with odds? Those are all the same, right? So really the only hard part about today's lesson is just reviewing factoring. I got x equals 0, 3, and negative 1. Over here we are starting down, ending up, so I'm going to do the same. Should label my x-intercepts, negative 1, 0, and 3. Going through negative 1, it's odd, I'm going to have to shoot through that. Kind of tight, right? Then through 0, shoot through again, and then through 3, shoot through again, and end through our arrow. So our end behavior is starts down, ends up. On the left side down, and then the right side up. Alright, so I look at this problem, it's asking me to factor this polynomial, but the steps we went through yesterday say, well, is it factored? Yesterday, a problem like this was factored, right? I see the parentheses, I see the binomials, right? This problem is not. So we're going to have to use our factoring skills to get it to be factored. Well, the first thing I'm always going to think about, always, is there a greatest common factor? Class, is there a greatest common factor there?
Yes.
Yeah. I'm going to show you guys a step. I would teach this to any student who's just first time learning greatest common factor. I write out all the factors of x to the third. And then all the factors of 4x. Class, do they have anything in common? They have an x in common. That's the greatest common factor. Then I just write everything that was not underlined or circled there. That would be x squared minus 4. Class, is that one factored? Are we done? No, we're not. So you can pay attention that I'm going to write something, as I showed you guys in the previous video. There's something called a placeholder. And why I call it a placeholder is because you're skipping, right? You have x to the second power, but you don't have x to the first power here. You put a 0 there. It keeps its place. And over here, we already know that this is x to the 0 power. As a super quick review of factoring, everyone say inside the parentheses. I'm going that in yellow. This is my method. I use the x in the box. I take the a times c, so looking inside here, class, what's my a value? And your c value. So a times c is -4. And what's your b value? 0. I'm trying to think of two numbers that multiply to be -4, but two numbers that add to be 0. What are those numbers?
-4 and 4.
+2 and -2. Now, if you watched my previous videos or your factoring test corrections, you guys remember that? The hint or the trick is, well, if a value is equal to 1, you only have to do the x. You don't have to do the box. So I have x times x plus 2, x minus 2. Class, is that in factored form? Yeah, and now I can just go through the steps of graphing it, which I'll do super quick. I'm going to find now my basic graph, so that's an x, 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 and if you multiply those, class, you get x to the third. Class, is that an odd or an even? If you don't know what a cubic function looks like, you go look at your basic graph, x to the first, and you'll notice that it does what? Starts down, ends where? Up. Is that called leading coefficient or end behavior? That's the end behaviors of the graph, the ends of the graph. So it's going to look something like that. Now we can just do something called multiplicity. You can use a quick chart. Helps me stay organized. Class, here, x is equal to 0, right? 0 product rule. X is equal to -2, and x is equal to +2. What's the multiplicity at, or the highest degree at x equals 0? So there's a 1 right there. So 1. -2? And x equals 2. And all of those are odds, which means you're going to shoot through the x-axis. So again, this graphing part should be the review part. Let's quickly graph this. So again, the goal for this whole week is that you can be able to graph the polynomial without your graphing calculator. X equals 0, x equals -2, x equals 2. And I'm going to look for my end behavior here, starting down, ends up. So this is kind of like you're going from left to right, your starting point and your end point. I forgot to write my x-intercept numbers, which is helpful. And if you really want it to be really fancy, you can also graph it with your y-intercept. So 0. If I put in a 0 there, that turns everything to 0. Does that make sense? 0 times 2 times -2, that'll all equal 0. So it's actually going to go through the origin as my y-intercept. So if I graph it, I'm going to shoot through -2. It's just going to go through it, and then it has to go back at 0, and then kind of shoot through again at 2, and end up there. So this is a graph of my polynomial. Only big idea difference from yesterday is you have to factor. X to the 4th minus x to the 3rd minus 6x squared. David, is this factored? How do you know it's not factored? There are no parentheses. Let's factor this. Abigail, what should we do first? Yes, what should we do? Do you know what the greatest common factor is? Abigail, what's left? X squared times something gives you x to the 4th. Vincent, if I factor this one, what does that become? So I have -6. -1, so those two numbers are -3 and +2. Class, is this factored? Yes, it is. Pamela, what should I do next? Basic graph. So I know it is even or odd. What's the easiest even you know? What's a smaller even number? X squared. And what does that look like? So we have a parabola opening up, so it's going to start up, end up. This is just a fancy word for end behavior. Everyone say end behavior. So our basic graph looks like that. Our leading coefficient, do we have a negative there, class? No. So leading coefficient basically tells you if it's going to, the arrows are going to stay up or if they're going to reflect over and go down. Okay. All right. So we have factored basic graph. Fabrizio, what do we do next? We're going to what? Okay, in order to do that, we're going to have to. So we went over, if it's factored, let's write that down. Is it factored? Yes, we answered that question. We did basic graph. What's next, Fabrizio? Let's do our multiplicity. That's just the chart. Here I need to set each of these equal to 0. Zero product rule. So 0 there. If I solve this one, I get the square root of 0 is x equals plus or minus 0. Class, can 0 be both positive and negative? No, so just x equals 0. So our 0 is x equals 0. This one will become what, class? X equals 3. And this one will become what? X equals -2. Okay, this one confuses students, the monomial. And you can essentially make this a binomial by doing this. This is really just x minus 0 squared. Do you see that? And the reason why I did that is to show you that its multiplicity or its degree or its exponent is what? Is 2 squared. Is that an even or odd? Kiss or shoot through? So kisses are evens. So this will be a kiss. What's its degree for x equals 3? What does it cost? What's its exponent? 1. So its degree is 1. Is that going to be a shoot or a kiss? It's a shoot through because this is an odd. And last one, x equals negative 2. What's its degree or multiplicity? 1. And 1 is a shoot through. Okay, let's go ahead and graph this. And this graphing part should just be a quick review. I have x equals 0. I have x equals, let's just say, 3. And x equals negative 2. I'm going to look at my end behavior now. It starts up, ends up. Alright, so let's go ahead and start here. We're going to go left to right. Enoch, from here, what do I do at the green? We're going to shoot through it. So go through it. Enoch, what do I do at the yellow now? So we're going to bounce off or kiss. Kiss and run away. And Enoch, what do I do at the pink? And we're going to end up here. So there's my graph. So in this problem, the only difference is that the polynomial was not factored and you just have to graph it. Yes, Crystal, and what is your greatest function? X. Tell me what's right. Raise your hand if you got that so far. Good job. Alright, inside here, what did you get, Ivan A? -1 and -1's correct. X times x minus 1, x minus 1. Ivan A, how do you write that together? Good. Raise your hand if you got that. And if that makes sense to you, that we have, really that's your x to the first. That's your multiplicity, that's your degree. So zero product rule. Again, someone asked, do I have to do that problem twice? The answer is no, because you already know that x is equal to what? 1. So you don't really need to write x equals 1 twice. But I think that student also recognized that it is called a double root, or a kiss, or bounces off the x-axis. So here I have x equals 0, x equals 1. The degree here is a 1. Yeah, I know, students are tripping. I have an even degree here. This is going to be a shoot through or kiss. Let's go ahead and graph this. Zero. X equals 1 here. It's going to be very close. Your end behavior is Mary Grace. What type of polynomial do we have here? Cubic. How does it start and how does it end? Odd. So what's the easiest odd? Linear. Starts down, ends up. Sketch your graph. I gotta go through the orange. I'm gonna bounce off the pink, kiss, and then go back up. And that's my graph. Alright, when you see a problem like this, you're probably used to things that are power of 2. So the first thing you're going to look at is the highest degree. And when you look at the highest degree there, you're going to take half of it. Class, what's half of 3? 1.5. Is that 1.5 right there? No. Okay. Because you can't take half of it, it tells you that you can't put them into binomials. Let me say that again. If you can take half of this value, and that's the next polynomial's degree, then that means you can factor into binomials. This one you can't. But the very first thing you should always do is take the greatest common factor, which is what, class? X. Then I'm left with x squared minus 2x minus 3. Can you factor that right here? Yeah, just as a quick reminder, I'm going to show you guys this one more time. Just watch more videos. Inside the parentheses, class, what's a times c? -1 times -3 is -3. Your b value? -2. I need two numbers that multiply to be -3. -3 and 1. Class, do those same two numbers add to be -2? Yes. Yes, they do. So I have these two values. That's what's going to be in my binomials. So I have x times the quantity x minus 3, x plus 1. Raise your hand if you got that. And then from there you can just graph it based on your multiplicity. Let's box that. Help us factor it. Caesar, help us factor this. Is that factored? So you should be able to factor this one here as well. Keep going. Raise your hand if you got that factored. So is it factored? We got it there. Now we're going to get a basic graph. Class, our basic graph is a? Is that an odd or even degree? What's the easiest odd? X of the first. Starts where? So this idea of starting down, ending up is called the end behavior. We're just looking at the ends of it. Okay? Let's get our multiplicity now. So our zeros, if you set each of these equal to 0, and if you solve these, what do you get? Divide by 2, x is equal to 0. Solve that one, you get -3 and -2. So x equals 0, x equals -3, and x equals -2. Now this one, if you ever get confused, you can always write this one as kind of like, looks kind of weird, but I don't think you would. But if it helps you understand it, you could. 2x minus 0. Does that make sense? What's its multiplicity here? What's its degree? It's a 1. So x equals 0 is this monomial, and it has a degree of 1. And do you shoot through or kiss? Remember, for odds, you do a shoot through. -3, they all have a multiplicity of what? 1. Let's go ahead and graph that really quickly. Pick your favorite colors. X equals 0. X equals -3. X equals -2. And we said that we would start down and end up. Vanessa, help us graph this. What am I going to do at the yellow? Gotta be careful, right? You gotta go back up really fast. How about at the green? So we're gonna go back down. And Vanessa at the pink. And there we have a basic graph of a polynomial function that's not factored, and we didn't use our graphic calculator. Melina, what did you find as your, what's the first thing you want to do? Thank you, Melina. What is the greatest common factor? And what's left? Uh-huh. Thank you. John, why did I leave this big old blank right there?
To use as a placeholder.
So what are you going to put in there?
0 plus 0x.
Now the reason why we do that is we're going from a binomial in the parentheses to a what? Trinomial. So now we need to see if we can factor here. Karina, let's factor this. Karina, what's A times C? -4 is correct, so I'm taking the A value as 1 and my C value is -4. Your B value, Karina? Karina, two numbers that multiply to be -4 but add to be 0. Thank you. Kaylee S., help us fill this in. Class, does the order matter? No. So here we have this now factored. Raise your hand if you got like Correct. Awesome. And then we can just go through our basic steps. We already know that this is x to the 4th. Class, is that an even or odd? That's an even. The easiest even you know is quadratic. X squared starts up, ends up. That's our basic graph. If you think about multiplicity now, I'm going to set each of these equal to 0. Zero product rule. If I take the square root of both sides, you're going to get x equals plus or minus. The square root of 0 is what? Is there such thing as a positive or negative 0? No, it's just x equals 0. Did you notice what I did out here? Even the greatest common factor you're setting equal to 0. This one becomes x equals 2, and this one becomes x equals negative 2. So again, I asked you not just to factor it, we are graphing it. In order to graph it, I figured out my multiplicity. These are my zeros. So I have x equals 0, x equals 2, and then x equals negative 2. Now we need to think about its degree. This one has a degree of what, class? 2. Is that an even or an odd? Kiss or shoot through? So evens we will kiss. Odds you will shoot through. Okay? Again, if you're confused on this one right here, you can make this x minus 0 squared. Do you see that? It shows there that your x-intercept is still 0 and your degree or multiplicity is 2. Kiss there. Natalie, here at x equals 2, what's its degree? Correct. X equals 2 comes from the binomial x minus 2, which has an exponent of 1. Shoot through or kiss? And Ducky, at x equals negative 2? The degree is 1. Shoot through or kiss? Shoot through. Let's go ahead and graph this. Think ahead as you're graphing. You have 0, 2, and negative 2, so they're pretty close to the origin. Color code it, looks nice. There's my x equals 0, x equals negative 2, x equals negative 2. I'm going to graph by my end behavior. That is starting up, ending up. And remember, we don't flip those because the leading coefficient, the a value here, is positive, so it's going to stay that way. Kate, help us graph it. What do I do going when I approach this orange here? Just shoot through it. Now what, Kate? So I'm going to go here and kiss or bounce. Then you run away. What's next, Kate? Shoot through. We're going to come back up. And we just graph polynomial by hand, not even looking at our graphing calculators.
Good morning, class. This problem tells us to graph p of x equals x cubed plus 3x squared minus 9x minus 27. Notice they have 4 terms here. 1, 2, 3, 4 terms, so you're not going to use Xbox. I'm going to show you how to do this problem using 2 GCFs. Remember, you can use your chart to recognize how many terms and what you do with it. Don't be intimidated by the p of x. So if you look at here, the first 2 terms, they have something in common. If you break them up into factors, you'll recognize that they have an x squared in common. I'm going to cover it up with this paper here, so you have x plus 3. X squared is a GCF, Now we're going to do the greatest common factor of the right side. That'll be a -9. You should have x plus 3. So here is my first greatest common factor. They both have an x plus 3 in common. Here and here. So let's put that first GCF out here on the outside. I'm pulling it out from the whole expression, so that'll be x plus 3. And then anything not in orange is x squared minus 9. Okay, hopefully you recognize why I have that gap right there. We're going to put in here a 0x. Why? So that you have a trinomial, and we could just move on towards using the x method of factoring. So x plus 3, x plus 3, x minus 3. And then you notice that you have something called a perfect square trinomial. Those x plus 3s, you have 2 of them. Well, you can put them together. Let's go ahead and do that. So x plus 3, quantity or multiplicity 2, and then x minus 3. So now we've factored it with 4 terms. Could have also used the box method of factoring. So now we have it in factored form. We're going to go ahead and figure out the basic graph. I'm going to go ahead and solve these here. X plus 3 equals 0. I don't want to do it twice, so you just do it once. Or 0 there is x equals -3 and positive 3. And you'll notice that my little chart here, first column here is x, that's my 0, so -3, and x equals 3. The multiplicity for the expression x plus 3 is there at the top there, quantity or multiplicity or exponent 2. And then that number 2 is an even number. So if it's an even number, then it's going to be a kiss. So the x equals 3 is the same thing as x minus 3, right? From there. That one has an exponent of 1, so its multiplicity is 1. That 1 there, is it odd or even? Well, it's an odd, so you're going to shoot through. Let's go ahead and draw a graph. So here is x equals -3. Let's go ahead and now in pink here, positive 3. And then now we can think about our basic graph, my arrows. Zoom out here and go back to the original problem. So it's to the third power or cubic. That's why it's the bottom left and top right, just like x to the first or a linear equation. The positive leading coefficient. That's my start here. And we're going to create a roller coaster. Starting in the bottom left there. Use a pencil, gotta be smooth. You going to kiss someone, you gotta be very smooth. Bounce off there, and we gotta shoot through.
Missing formulas in life. Problems becoming too difficult to clear? Well then, you need Mr. Math Cleaning Solution. Just spray the liquid formula onto the mess, then wipe it clear, and enjoy the result. Mr. Math. Stay clean and calculated. Order now at www.gpproductions.com and get an additional